AWS Solution Architect Associate High Availability. AWS Load Balancer Types: Application, Network, and Classic. Application load balancers are Layer 7 and application-aware, used primarily for HTTP/HTTPS and are more intelligent than classic load balancers. Network load balancers are used for TCP load balancing where extreme network performance is required, operating at the Layer 4 connection layer. They can handle millions of requests per second at very low latency. Also provide static IPs. A classic load balancer is a legacy elastic load balancer. You can load balance HTTP/HTTPS and use Layer 7 features like X-forwarding and sticky sessions, but classic load balancers are not application-aware. You can use strict Layer 4 load balancing for apps that purely rely on TCP. If an app stops responding, a classic load balancer will respond with a 504 error. A 504 means a problem with the application, not the load balancer. Logged IPs come from the load balancer. To find the originating client IP, look for the X-forwarded for header in logs. An internal load balancer is configured within a private subnet. Advanced config lets you choose which subnet to deploy into. No IP given for a classic or application load balancer, always addressed via DNS. Instances monitored by ELB are always either in service or out of service. Advanced load balancer theory. Sticky sessions allow you to bind a user session to a specific EC2 instance, instead of the classic load balancer behavior of routing each request to the instance with the smallest load. Sticky sessions can also be enabled for application load balancers, but traffic will be sent to the target group level. Cross-zone load balancing enables load balancers to distribute traffic to destinations across ASes, resulting in an event distribution across the endpoints. Without it, traffic would only be split at the AS level, which depending on the number of endpoints in each AS could result in an uneven distribution beyond AS level. Path patterns. You can create a listener with rules to forward requests based on the URL path. This is known as path-based routing. You can run general requests to one target group and requests to render images to another, for example. Auto-scaling has three components: groups, configuration templates, and scaling options. Groups are logical collections of services, app servers, web servers or DB servers for example. Groups use a configuration template to specify AMI ID, instance type, key pair, security group and block device mapping, basically all the elements required to start up an EC2 instance. The conditions on which a group scales, either based on the occurrence of specific conditions or to a schedule. 5 scaling options: maintain current instance levels at all times, if an unhealthy instance is found it will be replaced, scale manually, all you specify is the number of instances, auto-scaling makes the necessary changes to instances, scale based on schedule, scaling actions performed automatically on a schedule you set. Useful to respond to a predictable pattern, scale on demand, most popular, scales in response to demand thresholds being met, CPU or RAM utilization for example, use predictive scaling. Predictive scaling uses previous performance indicators to predict when scaling is required, and respond accordingly. Use EC2 scaling and AWS scaling combined to scale resources across multiple services to maintain optimal availability and performance. Auto-scaling will distribute instances across availability zones in the same manner as the instances being replaced. If you delete an auto-scaling group, the instances created by it are also automatically deleted, terminated. Architecture, always plan for failure. CloudFormation, automatically scripted build infrastructure stacks, with sample templates available. Quick Start gives access to some very complicated deployments. Rollback, specify alarms for CloudFront to monitor. Changes will be rolled back by CloudFormation if these alarm thresholds are crossed. AWS Elastic Beanstalk, designed for developers to easily deploy basic services with a single click and no AWS knowledge. It can also be scaled easily. You upload your code, AWS analyzes it and figures out what it needs to deploy. Elastic Beanstalk will handle the details of capacity provisioning, load balancing, scaling and application health monitoring.